Welcome to Beyond the Limit. I'm Matt Clark.
And I'm Mike Forsyth.
We're joined in this episode by Dr. James Kinross. Dr. Kinross is an Associate Professor in Colorectal Surgery. He is a consultant surgeon at Imperial College London, and he is also author of the fantastic book Dark Matter, The New Science of the Microbiome. In his book, Dr. Kinross argues that the trillions of microbes living inside our bodies are a fundamental, yet often overlooked force shaping our health.
So has modern living created an internal climate crisis? And has our reliance on antibiotics and our highly processed diet all severely damaged the diversity and resilience of our microbiome? And could this be the root cause of many of the so-called diseases of modernity, including allergies, autoimmune disorders and obesity?
He's really laid bare the facts, and he doesn't shy away from the controversial areas that have really grabbed the zeitgeist, such as should you go and get your microbiome tested? And actually, what can you do to improve upon it?
I loved his book, I really did, and not only because he managed to get both our names into the title. This is Beyond the Limits, and this is Dr. James Kinross.
Welcome to the show, James. Thanks for joining Beyond the Limits.
It's my pleasure. Thank you for having me.
I thought it might be useful if we could start by setting the scene and covering just a couple of basics. So what is the fundamental role of the gut, and what is the microbiome, and why is it important?
Okay. 3 meaty questions there, Mike. So I think there's lots of misconceptions around what the gut is and its role. And it's very much overhyped and it's everywhere at the moment. So there's a lot of emphasis on gut health. The gut is basically a long tube which stretches from the mouth to the bum, rather obviously. And different bits of the gut have different functions. Obviously, it has a critical role in nutrition and diet. Its primary role is to help us break down and absorb the food that we consume every day and to give us energy. Probably one of the more underestimated roles of the gut until, the last couple of decades has been its importance in our immunology. It contains a very large number of lymphocyte cells that, are a key part of our immune system that govern how we interact with the world. And I think of our gut really as a giant sensing organ. So you might think that you've got 5 senses, and I would argue that actually you've got like 100 trillion senses. You've got 100 trillion microbes in your gut, all of which that are constantly sensing the world around you. And your gut isn't just tasting the foods that you eat, it's tasting the air that you breathe, the environment that you live in. It's constantly interacting with the world around you. So your immune system is a complex, interconnected sort of web of different cells that help you interact with the world. And the gut will deal with more antigens in one day than the rest of your immune system will deal with in a lifetime. So it's dealing with an enormous amount of constant sort of interaction with our environment. And our microbes are a key part of our gut and a key part of our gut health. So your microbiome, which refers to a collection of all microscopic life forms, so it's bacteria, yeast, viruses, all sort of tiny little life forms, is an incredibly important determinant of your gut health. And your colon really is a giant fermenting engine. Your colon is where the majority of those microbes live. It lives in that sort of really sophisticated symbiosis that you have with your microbes. And so when I talk about the microbiome, I talk about it having a couple of key properties. The first key property is that it has a profound and important evolutionary basis. The microbes within us and on us are not there by accident. They haven't just fallen into our gut. They've shaped the evolution of our gut. They've shaped the evolution of many aspects of our biology. And so it's because of that evolutionary relationship that we have that really important symbiosis. And the second thing is that it has a time-dependent relationship with us. So the microbes that we're born with are not the same as the microbes that we die with. And the need or requirement that we have from our microbiome shifts with us through our various life stages. And actually, the third thing that I always say about the microbiome is that it's really, really individualized. So because it's so massive and because it's so variable, microbes that you and I will share will be very, very different at a species level. So you and I might have 500 maybe species of bacteria in the gut. At a species level, you and I will share around 10% of those species. They'll be very, very different. They might have core functions that we maintain that are the same, but actually it's really, really variable. And that's really important if you're trying to understand health, because that variance is a key determinant of health. And unless you have some measure of it, it's really very difficult to understand what health is and how you promote it.
I think interests me most about the gut microbiome from a function or a physiological perspective, and that's this idea of this communication two-way channel, this idea that it kind of communicates, say, for example, with the brain, and there's this two-way channel. Can you just explain a bit more about that and how that works?
Yeah, I can. So because you've got this really close evolutionary partnership, bugs have built this really nuanced molecular signaling language, and they can speak to each other. So they can communicate with bugs of the same species, they can communicate with different kingdoms, but they can also communicate with you. And some of that communication comes through the production of small molecules, or what we call metabolites, and they produce thousands and thousands of different metabolites. It might be through the creation of proteins. It might be hundreds of thousands of proteins that they create. It might be that there's a more direct communication, so that you can interact with the function of cells that produce hormones that line the gut, for example, or more directly with nerves that line the gut. The way that I often phrase it is, because it's so complicated and it's so difficult to conceptualize, I think about it as like an orchestra. So we talk about orchestral signaling. So microbes, much like a giant orchestra playing a symphony across your life course, will wake up different bits of the band to play different bits of any symphony at any given moment, depending on what you need, right? And they can communicate with you. So they're not all playing an instrument at any, one moment. They will come and they will go. And that orchestral signaling happens not just within us. So the maternal microbiome signals to the gestating infant, the gestating baby, through the production of these small molecules, and through that kind of cascade of molecules. So that orchestra is playing from mother to growing infant, and then that orchestra continues to play through our lifetime. Now, what you were referring to, I think, was the gut-brain axis. So because the gut produces these enormous kind of amounts of small molecules, it influences the function of all other organ systems that we have throughout the body. So we often refer to them as axes because it's a sort of simple way of thinking about it. So there's a very important gut-liver axis, for example. There's an important axis between the gut and the brain, as we've mentioned. It influences the kidney function, influences heart function, all these sorts of things. The brain is super interesting because it's perhaps a little bit unexpected. Like, why would the gut and the brain have such a dependent relationship? And to understand that, you've got to go back to early life and to development. So the gut and the brain develop together. And what I mean by that is that growing a brain is very, very hungry work. It takes an awful lot of energy, and a large proportion of that energy actually comes from microbes. But microbes also shape how synapses form in the brain, and they influence how those synapses are pruned as your brain develops. Your gut microbes influence the developing immune system in the brain. So about 15% of all cells in the brain are actually immune cells, they're microglial cells. And that evolution is influenced during your growth by microbes. So microbes influence how the brain develops. But then when you're walking around the world, experiencing the world, there's a constant two-way conversation between the brain and the gut. And some of that's direct. It happens, for example, through the vagus nerve or through the parasympathetic nervous system. So microbes are directly hardwired into that. So when they're unhappy, you might feel more anxious. But when you're anxious, your microbiome might change. They communicate through the production of neurotransmitters, or precursors to neurotransmitters, actually. So tryptophan would be a really good example of that. And they also influence the brain function through hormones. So they influence the production and function of lots of different types of hormones. And then finally, of course, through the immune system. The immune system is really, really, really important. So they've got multiple different ways through which they can influence, how we think, how we perceive the world, and how we respond to the world around us.
I'm so glad you mentioned the orchestra. Mike and I absolutely love an analogy on this podcast, and the orchestra is one I've used in a previous episode, which I was very fond of, that Mike not so much, but I'm really glad that you used that. We've also read that it's quite good analogy that you've described in your book about the Great Barrier Reef, and how, the kind of nurturing of the Great Barrier Reef is obviously very complex, but how this climate crisis is affecting the Great Barrier Reef, and how that's a huge, huge problem and a seismic change. What do you think are the key societal trends that are having the biggest impact on this very complex microbiome that you've just outlined?
So I'm going to answer your question, but before I do that, I'm going to unpick a couple of themes in your question, which I just think are so important that we should just briefly focus on them. So the first is, you talked about the barrier reef analogy. So for listeners who might wonder what the hell we're talking about. So the gut obviously has this complex ecosystem, and microbes coalesce around the lining of the gut, or the barrier of the gut. And the analogy is the barrier reef is a good one, because if you look at any kind of planetary ecosystem, life always seems to coalesce around the interface between two environments. So in that example, between the sea and the land, right? And it's the same in the gut. That's where all the microbiology kind of key activity is, in the gut anyway. And the importance of that analogy is because that's also where that kind of immune function that we talked about is co-located. So that's kind of a key part of where that communication occurs. But you also will have listeners that will know about something called leaky gut syndrome, or at least they might have heard around leaky gut syndrome. This idea that at some point that barrier fails and microbes cross the barrier and get into the systemic system. I don't really believe that leaky gut syndrome is a syndrome. I don't really believe that exists. But certainly, for sure, that barrier will fail, and when it does, it's catastrophic. But actually, the gut is designed to leak. It's designed to function like a barrier reef. It's designed to have microbes living at that interface, and occasionally microbes will cross that barrier, and microbes are in fact designed and have evolved to communicate across it. They are supposed to be there. And the key analogy then extends that when those ecosystems fail, those critical ecosystems fail, like in a barrier reef, actually that has planetary consequences. It influences the health of the entire planetary ecosystem, and that's a disaster. And the analogy therefore extends, because we therefore think that's why we have this rise in non-communicable disease risks in young people, predominantly driven by immune dysfunction. So allergy, atopy being really good examples, inflammatory bowel disease being another really good example. But just to sort of pick up on your other metaphor, you said you like metaphors, right? So the other metaphor that I often commonly talk in is this language of a climate crisis, because when you're trying to understand why the microbiome is so important, it's more helpful to understand when you think about, rather than who is there, you think about what we've lost. So we think through the process of industrialization, we've probably lost about 30 to 40% of the microbes that used to exist within the gut. So we can all understand that when you lose the biodiversity of an ecosystem, it's really bad for the planet and it's really bad for us. Well, the same thing's happening within us right now. Like, we are losing microbes. The challenge, or the nuance, or the difference, though, is that microbes are clever, and they evolve much, much faster than mammals and much, much faster than we do. And they have this ability to mutate and to share genes between species and adapt. So whilst we're losing microbes, the microbes that we do have are also adapting, and they're adapting really, really quickly. And the functions that they're developing as they adapt are not always conducive to us being healthy. And by extension, the language of climate crisis is helpful, because if you understand that the loss of biodiversity is critical, you can do something about it. You can change it. So actually, it's important to understand, because it gives you agency and license to make change. And that's really what this is about. It's about thinking about healthcare and medicine as a form of conservationism. It's about thinking about your internal biology as not necessarily just a mammalian human biology, but actually a shared, diverse ecosystem that needs to be nurtured, that has nuance, that needs to be protected, in the same way that our planetary ecosystem needs to be protected. So your question then becomes, well, why are we losing microbes? Like, what is the driver of this? Well, some of those things most of your listeners will think about or know about. So, for example, nutrition and diet. Like, we've had a globalized diet that has obviously changed over the last 10,000 years gradually, but it's, in the post-Second World War world, it changed very dramatically. So diet obviously is an important driver of it. But so is the process of urbanization. How we live has fundamentally changed. So we now live in super cities, that most of us do anyway. The urbanization fundamentally changes our microbiomes, because we're exposed to more environmental toxins, more environmental pollutants, but also because our social network changes, our social functions change. Our microbiome is dependent on people that we live with, who we grew up with, and that's shifted. But to me, the biggest drivers are medicines. So we consume an enormous amount of antibiotics, about 38 billion daily doses of antibiotics per year. But most of those antibiotics are not used in healthcare. They are used actually in farming and making sustainable foods for us to eat. And that has really been bad for the planetary microbiome. And we also take an enormous amount of drugs. Half the planet is taking a drug of some form every single day. So we're taking all of that polypharmacy, all of those multiple drugs that we take, has a big impact on our microbiome. And probably about a quarter of the drugs that we take are actually antimicrobial. We just don't think of them as being antimicrobial. So that might be medicines, for example, like proton pump inhibitors or non-steroidal anti-inflammatories. It might be medicines that we take to treat mental health problems. These things change our microbes. So we're trapped in this cycle around healthcare. Our prevention strategies at best change our microbiome, sometimes in adverse ways. And we're not really thinking about healthcare in terms of that sort of conservation strategy that I was talking to you about before. And some of those things you can make individual choices about, you can change. Some of them you can't. Like if you live in a city, it's really, really difficult to make that change, right? So some of these solutions are individual, you can make changes. Some of them you need policy. And in the same way that climate change needs us all to collectively come together, well, it's the same strategy.
I think it's really interesting picking up on the point of antibiotics, because as clinicians, when we are counselling about the use or non-use of an antibiotic, we're quite good at counselling about the risk of resistance. I think we're potentially less good talking about the possible deleterious effects it has upon your gut and your microbiome. And it's quite an eye-opener for me just to hear that, to think slightly beyond just resistance and whether someone actually needs antibiotics. I guess it works both ways as well, where I was listening to you talk and I thought that all makes a lot of sense. And then I thought of a situation where actually you're trying to say to someone, I think you need this antibiotic, I think you do need this treatment. And then the pushback that would potentially come of saying, actually, we know this has a massive effect. I'm worried about this myself as a patient.
It's a really contentious thing. And I don't want there to be any ambiguity, because some of your listeners might be listening to this thinking, oh my God, I've got pneumonia and should I be taking it? Yeah, take the antibiotic. Antibiotics are critical life-saving medicines that we desperately need. And we should be profoundly worried about antimicrobial resistance. Like, this is a catastrophe of epic proportion. And, we're already losing patients in the UK each year from antimicrobial resistance. So we're going to lose an awful lot more very quickly. And antibiotics are incredibly important. But the other thing that I would say is that antimicrobial resistance is a sort of biomarker of our failure around microbial conservationism. Like, if you're seeing antimicrobial resistance rates, you must be thinking, bloody Nora, if we've got resistance rates that high, just think of the catastrophe that we've caused to these important bugs. And of course, you find antimicrobial resistance genes to kind of modern antibiotics in the Antarctic tundra. You find them in the soil. You find them in the oceans. They are everywhere. You cannot escape them, right? So, and the other thing that I would say is that the key thing about antibiotics is not necessarily just taking a dose of antibiotic. If you have a dose of penicillin, it's not going to trash your microbiome. Your microbiome is probably going to bounce back and probably be okay. And it won't be that long lasting. The problem comes when you have multiple doses of penicillins over multiple years. So you're having serial dosing, or you're having broad spectrum antibiotics, particularly like macrolides and these sorts of antibiotics. And you're having them at critical moments in your development. So what I said in my early spiel is that the microbiome is time dependent. So if you look at the data from kind of Scandinavian studies, longitudinal Scandinavian studies, kids, young children having recurrent doses of macrolides, they all have rising rates of obesity. They all have rising rates of asthma. They all have rising rates of allergies and atopies. And this is really nice science, really well executed science. And you see the same epidemiological data. So you're asking about bowel cancer. Mothers who get recurrent doses of antibiotics will have offspring at higher risk of bowel cancer. Young children who get higher doses of antibiotics or recurrent doses of antibiotics have a higher risk of bowel cancer. Adolescents, same thing. It goes on and on and on. So it's hit after hit after hit after hit. And that's the problem. Actually, my favorite story about antibiotics, if you go back in the 1940s, when we first kind of discovered them and we were industrializing them, their first use cases were not in healthcare. I mean, yes, they were used famously, at the Normandy landings, and yes, they were used to treat people, but actually they were used in farming. And by 1946, we knew that if you gave antibiotics to a chicken, guess what? It gets fatter faster.
I know you mentioned about the conditions that are linked or potentially linked to an imbalanced or a deficient microbiome. I was reading a little bit about bowel cancer, dementia, as you say, inflammatory bowel diseases. Is there the evidence yet to back up the feeling that the effect on the microbiome is causing these, or is correlated to these, or is it very much theoretical concerns at the moment?
So I think microbiome has been a science that has endured this death by association. Association is not causation, and that's the key thing. We've got mechanistic and we've got epidemiological evidence. The challenge comes is when you get this sort of tension between I'm going to sound like a real old pretentious knob here, so forgive me. But the
No,
tension
you'll fit right in on our podcast, James. Don't worry.
balance between classic reductionist science that says, number one bug, one disease, one pathway. It's a Cox postulates kind of model, right? Which completely falls down in microbiome science because actually it's the functions of communities of microbes together. So it's as much about the dominance of pathogens, so bugs that cause harm, and the loss of symbionts, like microbes that you need to protect yourself. And it's the timing of that loss that's critical. So if you're trying to study a disease like bowel cancer and you're looking at the bugs at the time that someone's got bowel cancer, well, that ship has long sailed. The horse has bolted. The problem was in early life. So in my group, we study infants, from birth, because if you want to understand your risk of non-communicable disease, you've got to understand the evolution and growth of the microbiome in early life, because it's priming the immune system. It's priming, your mutational and immune burden that you're going to have to deal with the rest of your life, and setting your gut up to deal with the environment that you're going to be living in. And if it goes wrong, it's not good. So the other thing that I would say is that even if you go to a reductionist model of one bug, one disease, we are starting to tease out some stories. There's a large number of what we call alpha bugs or keystone pathogens that we think might be really important drivers of bowel cancer, right? So in bacteria, it's Fusobacterium nucleatum, or it's E. coli and the Colibactin story. Quite nice, elegant science around these things. So at the moment, we couldn't have necessarily called them carcinogens, but there's really good evidence they're bad. And if I find them in my patient's gut, I will be thinking, okay, what do we need to do to kind of meaningfully change things with them? So that story is coming out and we are beginning to see it. But it's taken a long time because the science is really complicated. It's really complex, communities of bugs that you're dealing with over time. And to do that, you need different kinds of trials, and it's taking some time.
I think that's a really nice, tangible nugget that maybe us GPs can start wielding a bit more with our patients, though, in terms of it always falls flat when I'm saying, with a patient who really wants antibiotics for their chest infection that is probably viral. In a 10-minute consultation, we have to then try and sensitively explain to them that this is probably not a good idea. You're trying to negotiate with the patient here. And if there are actually now studies showing implications later in life and how actually antibiotics, particularly repeatedly, might be damaging, that's quite interesting, isn't it?
One of the things that I often do in that situation, so in my clinical practice, I now see lots and lots of patients with, functional gut problems that are all caused by antibiotic misuse. So the classic example is acne in adolescents. They're on 2 years worth of, some god awful antibiotic, and then they wonder why their gut doesn't work in their 30s. Or it's recurrent urinary tract infections. That's the other kind of classic, like urologists just giving dose after dose after dose of antibiotic, and it just causes chaos. So the analogy that I often use, just to give you perhaps another metaphor, a third metaphor, Matt, in the space of about 30 minutes. It's like saying, well, look, okay, you had this lush meadow that was full of wildflowers, and it's gorgeous, and it was rich, and it was diverse. And diversity is a good measure of health. Like, we all know that. And you've just set fire to the whole thing. The whole thing's burnt down, and it's full of tall weeds, and it's not nice and diverse. You don't keep burning the weeds down expecting the garden to grow back. That's not what happens. It doesn't work. Right. Part of health and part of your defense against pathogens is having diversity. It's having microbial diversity. And so actually, if you use the garden analogy, so actually what you really need is water the garden, feed the garden properly. You've got all the, kit to do that nurturing, because all of your prevention strategies, a lot of the reason that they work is because the microbiome is part of how they work. So exercise is a really good example, but it's just not talked about and therefore not thought about, right? But it's part of it. And so you can say, well, all of these things are really important. Actually, what's much more important is that, you really think about nutrition and diet, that you properly rest if if you've got a viral chest infection, all these sorts of things. And then it suddenly becomes actionable, I think.
I just wanted to also touch on, you mentioned the industrial age, or the industrialization of civilization. I want to bring it down to kind of slightly less fancy terms, and things like Deliveroo and Uber Eats and these other kind of societal trends that the adoption of these technologies, because they're great, aren't they? They're, food delivered to your door. But are there other things other than antibiotics that we're all doing, on a societal level that are scoring own goals?
Food delivery apps, I think, are profoundly bad for our health. And one of the reasons that I think that almost should be labeled carcinogenic is because it's not just that they encourage us or, they egregiously market to us the worst foods for our health. Uber Eats has an annual food report and it's depressing reading, right? It's always number one is cheesy fries, right? And people just don't want to have any fiber or any vegetable. But it does another couple of really dangerous things. The first thing is it takes away all responsibility for the food that we eat from us as consumers. The ingredients that we choose are fundamental. They're absolutely fundamental to the quality of the food that we have and therefore to the benefit that we derive from it or the harm that perhaps we experience from it. But also how we cook it has such a big impact on defining the nutritional properties of our food. And then who we eat it with, like who we eat food with is also really, really important. If you're cooking and preparing a meal, and your hands are literally in it, right? Skin microbes are going to definitely get into what you're cooking, but also you're going to share that meal. You're going to have a kind of communal experience. And what we know is that families that have shared communal experiences or who are part of meaningful social networks where they actually are in the community with their friends in their networks or have more diverse microbiomes, like it's a basic measure of health. So it kind of, these food delivery apps, they rob us of all of these things. It's, yes, I'm a microbiome geek, so I am interested in the microbiology of it. But actually, from a societal perspective, I just think they're really, really bad for us. And we should definitely not be using them.
We've talked specifically about harms to the microbiome in terms of environment, antibiotics, as we talked about processed food and food delivery, as we mentioned. What else is there? So I think, alcohol, stress, these kind of things, is that going to play a big part?
So the answer is that if you think about key determinants of health, so the genes you're born with are really important, but they probably only explain about 25% of your health determinants. And most people in the kind of science or health will talk about gene-environment interactions. It's like the foods you eat, where you live, who you share your life with, all that sort of stuff. I think about gene-environment microbiome interactions because your microbiome physically sits between your genome and your environment. It literally and metaphorically sits there. And it's that critical as a sort of determinant. So the reason I say that is everything that you've mentioned, therefore, at some point has to interact with the microbiome. Either it will change the microbiome or the microbiome will influence its risk to your health or maybe the derived benefits from your health. So alcohol, really classic example. Alcohol is so interesting because, of course, so much of it is based on fermentation for its manufacture. Like we literally rely on microbes to make the booze that we drink, and it often contains microbes or yeast for that kind of very purpose. But also alcohol contains lots of sugars, it contains lots of polyphenols, in some cases it contains lots of things that microbes really love to eat and in fact rely on. So your microbiome really changes with alcohol consumption, and it has a very big impact on determining your risk of liver disease and these sorts of consequences from too much alcohol consumption. Therefore, the quality and the type of alcohol you have, just like antibiotics, becomes really important. If you're drinking lots of blue alcohol, like it's probably really, really bad for you and your microbiome, and I would really recommend you don't do it. We drink like way, way, way too much ethanol. Like in the UK, I think we drink on average each about 14 litres of ethanol a year, right? We just drink an enormous amount of it. And we've got to stop drinking. Like drinking is really, really bad for us, but nonetheless, we do it. We don't exercise enough. We don't get out into nature enough. Unless you are exercising 3 to 4 times per week and getting your heart rate up. I mean, there's a million reasons why you should do those things. And most of those things have got absolutely nothing to do with your microbiome, but it does change your microbiome. It absolutely does have an impact on it. When you're out running in a wood or you're interacting with nature more meaningfully. So gardeners, for example, gardeners have a very different microbiome depending on the season that they're gardening in and when they're in the garden. And they have very different microbes in their gut to non-gardeners. But there is a meaningful connection to it. Here's another good example. Kids who go to forest schools have different microbes to kids that, are in urban nurseries. And there's been some quite nice studies introducing kids in kids' schools to forest schools longitudinally, or introducing them to animals and bringing animals into their play areas. It really, really changes their microbiomes. So that exposure to nature is really, really important. Conversely, if you're in an urban environment and you've got lots of plastics or microplastics or, environmental toxins, that's going to have a really, really big impact on your microbiome.
I think there's a growing awareness now that the gut microbiome is important. I think the understanding is growing, and I think it is also resulting in this kind of growing capital market of tests that are available and certain hubris that surrounds this. And obviously there's bad actors here trying to make some money as well. But it would be nice to, now that we've talked about how a diverse microbiome is important and how we need to nurture it and look after it, people are asking, do we need to test our microbiome? Are there ways in which we can test our microbiome, and how do we define a healthy microbiome with these tests?
So some brilliant themes. And again, I'm going to slightly unpick them because there's two or three here. So the first thing that I just want to say is that I'm a colorectal surgeon. I specialize in the gut, and I believe the gut is the most important organ in the whole body ever. And I think the gut microbiome is the most interesting microbiome, but it is not the only one, right? So we shouldn't be too gut centric, because actually there's a very, very important skin microbiome. There's a very, very important lung microbiome. There's a very important urogenital microbiome. The vaginal microbiome is a key determinant of female health, almost never talked about. And it really, really important. It influences everything from lots of different aspects of sexual health, but fertility, menstrual health, like really, really, really important. All of these things are profoundly connected. But if we follow your line of reasoning, which I think is a sensible line of reasoning, then if it's important, well, of course we should be measuring it. Absolutely, we should be measuring it. But the problem here has come because the cart has gone slightly before the horse. So what's happened is that microbiome science was a science that kind of grew at the same time as social media. Like by the time the first really important piece of work being done, so early 2000s, social media, it kind of grew up with social media. And immediately, VCs decided that this was something that they could profit from. And you're right. There were a lot of Wild West companies making grandiose promises, selling tests that were basically meaningless, and also perhaps doing it very badly. And there were a lot of very high profile failures. So a lot of companies just went bust. And actually it has been the Wild West. And the part of the problem with microbiome testing is, to your point, we can't really define what a healthy microbiome is. Now, that's not strictly true. We can sort of define it. But like the broad question is, well, do you define it by who is there? And can you say with a degree of accuracy, okay, in a 20-year-old man or a 30-year-old woman, actually, we can be really clear about which players in a microbiome are important to defining health? Or do you have some sort of measure of, ecologies, like diversity, for example? Or do you have a measure of function? Do you look at particular molecules that they're producing and say, okay, they've got these molecules, therefore they are healthy? Now, there's a couple of problems in doing that. The first is that we have not completely mapped the microbiome. We don't even really know who is in the microbiome. Like, I'm talking like we've decided who was there. Well, we haven't. So to give you an example of that, like I think I said at the beginning, the average person has about 500 species of bacteria, right? There's probably been about 2,000 species of bacteria defined or measured in the human gut across all microbiome studies. It's about the same number of species of trees in the Amazon rainforest. So it's actually the diversity of bacterial life forms in the human gut is dwarfed by that of viruses. So there's probably about 150,000 species of viruses in the gut. And we've got no understanding of them. They don't exist in our databases. We don't know what they're doing to us. We don't know how they're shaping bacterial life forms. We don't know whether they're causing disease. It's just completely unknown science. We have no knowledge of how small, abundant microbes in the gut really influence our health. So fungi, for example, or yeast, and how they interact with bacteria and what that relationship means for our health. So that's why my book was kind of called Dark Matter, because basically there's this big gap in our medical knowledge and understanding of what happens. And so at a sort of genomic level, there's like 23,000 genes that code proteins that make a mat or a mic, right? And there's probably about 30 million microbial genes in your gut alone. So you're like 1% human at best. You've probably got the same number of microbial cells as you've got human cells. So at a cellular level, you're equal human microbe. And so you're a super system. You're like a superorganism. And in everyday medicine, we measure none of it. You measure a handful of microbes and we think, oh, we better have some antibiotics. So we're feeling our way in the dark. That's literally what we do every day. But my strategy to answer your question a bit more precisely is, well, I think it's better to have some knowledge than no knowledge. So I would rather use a test that's imperfect and understand that test's limitations and use it in a way that I think I can maybe change the way that I treat someone helpfully than not have that information at all. So I do use microbiome testing in my clinical practice, but I use very specific tests. which are based on very specific sequencing technologies, which I really trust, that are really robust, that give me the same information that I need every time. And I use those tests in a very particular way. So I use them longitudinally in my patients. So I try and measure them when they're healthy, because when you're healthy, that's the best time to measure your microbiome, because that's your fingerprint of your microbes. So you've got a moment in time where you know what was in your gut at a moment of health. Therefore, when you become unhealthy, I can begin to answer, okay, well, you've lost this, or you've gained that, or you're missing that. And then, of course, you're using it in a way that is designed to inform therapy. So it's very helpful for nutrition and dietetics, for example. And it can be very, very helpful if you're trying to diagnose functional problems in the gut, because sometimes when you begin to do this routinely, you start to see things that when you begin to do the microbiome test, you think, oh my God, well, of course you've got bloating. I mean, your gut is absolutely full of E. coli, and that is wrong, and we need to do something about it. So I think, it is helpful. Do I think these tests should be direct to consumer? I'm slightly more skeptical about that, because I think part of the problem with these tests is, if you've ever done it, you get like an 80-page report, and it's just absolute bullshit. It's just full of nonsense, right? It's 80 pages of absolute, like, I can't understand it, and I'm a microbiome.
You've done it, haven't you, Mike? Have you done it?
Yeah, I was dying to come in there, because a slightly running theme of this podcast is mine, and possibly Matt as well, a slight midlife crisis and just going from fad to fad. And I tested my microbiome. I did one of those home tests, which
company you used?
Yes. I don't know if we are. And actually, I've had a complete mind blank who it is, conveniently. Yeah, so the results, it was interesting to see. So sort of massively overshare with our listeners. I was told that I had a low diversity of microbiome, but that my gut health score was, I quote, good. And I think the advice was, therefore, I had to then scan every item of food to see which was the most beneficial for me. Interestingly, I was blastocystis positive, which they told me, I mean, I don't mean to gloat, but apparently only 30% of the population are positive. So form an orderly queue, ladies.
Oh, God.
But I'm going to edit that out. But I think I was interested in you saying that, because you got this 80-page report, and they had sort of cutesy named all of the bacterias in Stella and Sarah, and this is Ella. And I mean, I know it's not very user-friendly to give them their whole Latin names, but it did feel like a sort of, in fact, if you'll allow me just for a moment, I'm going to go a little bit philosophical, but it reminded me a little bit of this concept that I was reading about called cruel optimism, which is this theory that complex health issues can be resolved essentially if only you did a little bit more, or if you were a little bit healthier. And it just felt like a real oversimplification of what is clearly just incredibly complex science. And I'm just interested to hear your thoughts on that.
So I mean, 100% agree with everything you're saying. And I use these tests. The first thing I say to them is that this test cannot tell you whether your gut is healthy or not healthy. It is not a diagnostic test. Any test that's telling you that is marketing. What they can tell you is whether or not your test is an outlier. So whether or not your test is different to their baseline data set. But their baseline data set doesn't tell you whether or not those people are healthy or unhealthy. They don't have that information. If they do, they shouldn't have, and that's equally more problematic. So what you're trying to understand is, are you an outlier? And if so, why are you an outlier? And actually, in microbiome testing, therefore, precision becomes really, really important. I really want to know precisely, not actually just what species you've got. I want to know what strain of bacteria you've got in there, because actually I might want to track that over time. And precision is everything. And the other thing is, if you've got blastocystis in your gut, you probably shouldn't have. It's a parasite. You need to know, right? So actually how you act on it then becomes incredibly important. And one of the things that many of these tests do is try and sell you supplements. There's an upsell. Right? It's like, okay, you've got this. You should have our supplement. You should have this, which is equally really problematic, because they overly simplify treatment and therapy in a way which is not helpful. So it's like, you should take this probiotic, you should take that probiotic. Well, maybe, but maybe not actually. And quite a lot of the patients that I have that I, sequence get deeply frustrated because they've got these really awful symptoms, and their gut microbiome test comes back saying, actually take some inulin and everything will get better. Well, no, they've probably been taking it for years. So there's nuance and subtlety in it. And actually good tests that are done really, really well have very precise technologies of sequencing. They will not give you fluff. They will just give you the detail. And actually they should be giving you information that is actionable. Like, what do you actually need to do about it? rather than, leaving you with stress and anxiety about something that you may or may not be able to control. So, but listen, we should look at your data and go through it, Mike. I'll be very happy to do that. If you send it to me, I'll send you back some thoughts.
Thanks, James. I appreciate that. You slightly burst my bubble there with the blastocystis. I swear they were telling me that was a great sign that I had that.
I don't know. Maybe it was something else, but maybe, I don't know. Send it to me and we'll have a look. But generally, that's also a good thing.
So am I reading the tea leaves right here? It sounds like these are incredibly complicated tests that actually you as an expert sometimes are, still grappling with the interpretation of, and these tests given into the public, it's almost kind of meaningless or uninterpretable to somebody who doesn't really know what they're doing.
It's not meaningless. It's helpful. But the problem is not the test. It's the way that it is marketed, and it is the way that it is communicated. And it's about not overhyping something and giving information in a way that's actionable and interpretable. Like saying, you can sequence your whole genome. I'm going to go and sequence the Matt Clark genome, and I'm going to give you your whole genome. Well, what the hell do you do with that? Like, you just don't know. You don't know what SNPs are or not. You don't know which mutants are important or not, unless you're a clinical geneticist, in which case it might be helpful. So I think that's been a trend in consumer health at the moment. It's just, we're just going to give the consumer lots and lots of information. And quite often it just creates health anxiety because actually it's given in an irresponsible way that is not helpful. But in the right hands, and if you're using that test in the right way and it's done the right way, well, actually it can be really quite helpful. Like if you're doing a microbiome analysis because actually you've got a particular clinical problem, actually I find it changes my clinical management very frequently when I do it. And also, the most helpful microbiome analysis is the one that's normal, because quite often you get to go, this is normal. Your problem is not microbes. Can we now move on and try and fix the actual problem that you've got? Because the problem with microbiome science is that if we take my assumption or my hypothesis that the microbiome is really, really important for health, but incompletely understood, it becomes like this misrepresented, or this science is very easy to manipulate so that it can say whatever it is that you want to say. So health influencers can say whatever they want about the microbiome. It's very hard to disprove or to prove. It becomes nonsense. And quite often in my practice, I'm dealing with clinically vulnerable people who may have been failed by, traditional medicine, or who have really difficult problems that are hard to fix. And they come and they sit in my office and they go, "Doc, it's my microbiome. Here's a Zoe test." It says it, and you have to go, "Oh no," you got to unpick it. So having a normal test that you can go, actually, your microbiome is normal. I think this may not be the problem here. I think it might be something else, is actually also quite helpful.
So let's move on then, so that our listeners can have some actionable insights into what they might be able to do to improve upon their gut microbiome. And we've outlined exercise, social contact, etc., etc. Are there any kind of specific things that you'd say, what? If you're going to do one thing, or if you're going to do a couple of things, is there anything that you can kind of tell the general public how to behave or how to act upon that might improve their gut microbiome for the better?
Yeah. So I was going to be flippant there, but behave badly and have fun. I think having fun is a sorely underrated thing, which is really important for longevity more broadly. Like if you're not having fun, actually that whole gut-brain interaction, that whole gut-brain axis is going to be off kilter and you're going to be more unhealthy. So fun, number one. If you can't have fun, eat fiber, lots of it. Eating fiber isn't always the funnest thing. It can be like eating cardboard if you don't do it right, and you can make you fart like a racehorse. But it's interesting fiber because we've known since the 1950s, 60s, and certainly 70s that the precipitous drop in fiber consumption in human populations correlates very, very closely with the rise in multiple different non-communicable diseases, right? We've known that for ages. And it's been very difficult to translate that into, prevention policy that really meaningfully, is easy to enforce. The microbiome is a key reason why eating fiber is so good for you, because microbes in the gut ferment fiber and turn it into lots of molecules that you really need for maintaining health. So the average person eats around 15 grams per day of fiber. In the UK, you probably should be eating double that at around 30. Science that we've done with our African cohorts, they're eating around like 50. So fiber is the simple, cheapest, most important food that you can consume to improve your health more meaningfully. Just 7 grams more fiber per day, you reduce your risk of cardiovascular disease, diabetes, obesity, cancer. Just about everything gets better. So it's the number one thing. Not everybody can eat fiber in huge amounts because the Western urbanized gut struggles with it. And the reason we struggle with it is because we just don't have the microbes that have those fermenting enzymes within them to do it. So you bloat and you feel uncomfortable. So if you're going to do it, you've got to do it slowly. You can't just transition to 30 grams tomorrow. You'll blow up like a Zeppelin. You'll have abdominal pain. You'll be on the loo and you'll hate me. So you've got to do it slowly because you're growing a garden. You're fueling a garden, right? You're dealing with live organisms. So do it slowly over a period of 3 to 6 months. Just slowly build it up. Let your gut grow with you and evolve with you, and it will develop the enzymes it needs to be able to metabolize it. Have lots of different types of fiber. Fiber is not a homogenous thing. Like, as the social influencers say, eat the rainbow. That's great. Lots of different colored vegetables and fruits and things are really, really important. But actually, good old bit of roughage is really, really important as well. So fiber, like that's my number 2 thing. And then my number 3 thing is, like, you really should try and avoid polypharmacy. So polypharmacy means taking lots of different medicines at the same time. And that gets a bit more problematic as you get older. So particularly older patients will often, in my practice, will, and you guys are GPs, you see it the whole time, they come with long lists of drugs, right? So really trying to minimize the amount of medicines that you take and why you take them. And sometimes we take medicines because it's just easier than not taking medicines. Like, sometimes we really need to take the medicines and they're really, really important. And sometimes we don't. Because actually doing that exercise is a bit hard. Actually making those nutritional changes is really hard. Sometimes, it's harder to modify our lives and to have that sustained behavior change than doing it. But actually, when you have these drugs, it's really not good for your microbiome. It's really not good for your gut. It's much better to more meaningfully invest in prevention, protect your microbiome and have a health through that conservation approach for the gut.
So that's all seems like really sensible advice about how to boost the microbiome. Are there more specific treatments then? I know, interesting reading in your book about fecal transplants. Is that the future? Is that the present? Where are we going with that in terms of more kind of specific treatments to enhance someone's microbiome?
So for those of you that are listening to this and think, what did he just say? Yes. So fecal transplant is as gross as you think it is, and it is what it sounds like. So it's taking feces from someone who's healthy and putting that into someone who's unhealthy. And feces, is obviously predominantly made up of microbes. About 60% of wet stool weight is bacterial microbes. The reason you give a fecal transplant is because you're giving the whole community of microbes all of the molecules that they make that are necessary to sustain that whole ecosystem. And fecal transplant's been used for many thousands of years, and it's become increasingly common in the treatment of pathogens that affect the gut. And Clostridium difficile is the most common one. It's NICE approved for use for C. diff. Probably about 90% of people that would qualify for FMT or fecal microbiota transplantation for recurrent C. diff can't access it because we can't produce enough of it. But there has been a rapid growth in the FMT industry because the microbiome is important, all these conditions that we talked about before, well, then the theory becomes, well, why can't we just give a whole nice new community to someone who's got ulcerative colitis or someone who's got obesity, and will it just magically make it all go away? And the answer is, of course, disappointingly, it's more complicated than that. And the reason it's more complicated than that is that actually you're giving live microbes, and live microbes need a nice niche to grow in, and they need to also be able to sustain themselves. And if you're doing that for a chronic disease, which is driven by a nuanced, perhaps complicated interaction between the immune system, for example, and microbes, it's not quite as simple as treating a pathogen. With C. diff, you can take any feces, stick it into the gut, it'll get better because you're just going to outcompete that pathogen and it will go away. It's not the same if you're trying to treat a condition like obesity, which has got multiple different drivers. So we are seeing, I think now there's about 400 randomized controlled trials globally for FMT. We're seeing it used in a diverse array of conditions. So, for example, depression, we're seeing it used in the treatment of anxiety, autism, also things like addiction. You were seeing it used as a treatment for obesity and cardiovascular disease. And we're also seeing it most critically as an adjunct in the treatment of cancer. So if you look at very expensive new classes of medicines, like biological medicines, so that modify the immune system, there's a particular class of medicines called immunotherapy or checkpoint inhibitors. These FMT therapies transform how those drugs work. So you're seeing them given as an adjunct to these medicines as part of treatment, and there's multiple different trials going for that. We're seeing a change in the way that FMT is given. So we used to give it as what was rather unattractively known as a slurry. And that slurry would be given down a nasogastric tube, or it gets put up your bum via a colonoscopy, and it's pretty gross. Now we give it as what is comedically known as a crapsule. So like it's a freeze-dried, lyophilized capsule, which you take as a normal tablet, and it's a bit more palatable. Is it the future? No, it's not the future. At the moment, it's a blunt instrument. And in the same way, you wouldn't just take a kidney from one person and slap it in the other. Actually, what you want is a degree of precision. So you can map the specific functions and immune requirements, or maybe the kind of determinants of engraftment from an individual into another. That's what we need in fecal transplant. So the way we're going is to more precise science where you can say, well, okay, Mike needs an FNT. What is the ideal FMT for Mike? Can we go out and find that donor and make sure that it maps more precisely? Or it's saying, well, actually, we're not going to give the whole community. Like, we don't want to give, just a random dump of a random literal and figurative dump of microbes. What we're going to do is we're going to actually just give a very targeted community of microbes, because actually you need a specific set of functions, and we're going to synthesize that in a lab and we're going to give it to you. Or can you go a step beyond that even further? So what we are also working on is this field of synthetic biology. So synthetic biology is, can you engineer very specific bacteria, phage, yeast, viruses, whatever, to literally be a pharmacy that you consume? You take that bug, it goes to whichever organ that you need it to go into to deliver a drug, or to have a particular effect on the bit of biology that you're interested in. And that's definitely where we're going. And that brings up a whole other set of ethical challenges around whether or not you would really want to take a genetically modified probiotic. That's an open question.
And also, going back to the analogy, if you've got your orchestra, but you're then saying, right, okay, we're missing the percussion, let's prescribe the percussion. How do you stop the percussion element of the orchestra drowning out the wind section, or grabbing the trumpets and starting to smash the drums with the trumpets? How can you? It's such a complex equilibrium of organisms. How do you?
It's a complex metaphor. The metaphor is complex, but the science is even worse. So the answer is that you can, in theory, you can, actually begin to target particular microbes. So, for example, you can repurpose old antibiotics and give them in a very targeted way. Or you can actually give phage therapy. So phage, viruses that attack or infect bacteria and knock down selective microbes. You can use nutrition and diet in a targeted way. You can begin to engineer ecosystems. But what we're doing in our lab, I work with an amazing scientist at Imperial, is actually creating micro robots, like bacterial robots. You can steer them, and you can do that in quite clever ways. So the science is quite futuristic, and it's sort of catching up, and we're slowly being able to target it. And in fact, actually, if you look at microbiome science over the last 20 years or so, what we haven't really had in microbiome science is a blockbuster company that's come out, that's created a new technology that's transformed our health. Like, it's been this great promise, and it hasn't really delivered. And one of the reasons it hasn't really delivered is because it's just much more complicated. Every time we understand it, we discover another layer of complexity that we didn't know existed, and it just keeps going and going and going. But the thing that I would say, though, is just coming back to the beginning of our conversation. We started talking about this concept of climate crisis, right? The gift of the microbiome is not in therapy, it's in prevention. We have an unsustainable, unaffordable healthcare system with an aging population and a growing burden of disease. We're living longer than ever before, but we're not living happier than ever before. How are we going to live happy? Well, you can only do that sustainably and affordably if you prevent these things from happening in the first place. And the gift of the microbiome is in prevention. So actually, it comes back down to the beginning of our conversation. It's, how do you set up the microbiome in early life? How do you protect it at key moments in our development, like puberty? How do you sustain it when we become older, to maintain our brain health, for example, and prevent dementia? And to do that, you've got to have some legislation. You've got to have effective policy. So I believe that actually what we should be doing is protecting the maternal microbiome. It should be a basic human right. If you're trashing the maternal microbiome, it's bad for maternal health. It's a disaster for the gestating infant. We should be protecting it. We do this in other aspects of climate change, but we don't think about ourselves internally just in that way. It's just not how we perceive our human health. And so what I'm trying to do in the way I communicate microbiome science is just to get people to think a little bit differently about their health. Your health is determined by a complex ecosystem that you really need to nurture. And it's the nurture that's the key, or should be our kind of main emphasis, I think.
I just wanted to ask you one more question, because you are now, clearly you're a prominent voice on gut health. And there are other prominent voices. We've mentioned, one of the companies earlier in this podcast already. But I'm just wondering, with the likes of you, Tim Spector, Justin Sonnenberg, these other people who are, clearly excited about this area as well, are there any key areas that you feel like that you disagree on?
I think disagreement is good and should be encouraged. Like, that's how we move forward. I think if we're all saying the same thing, then that's no good for us. Like, we should be disagreeing and, I suppose, nick a phrase from one of your competing podcasts, which I know you're in a similar audience numbers as The Rest is Politics. But I think, it's that we should be agreeing. What's it? What do they say?
Disagreeing agreeably, isn't it?
And that's what good science should be. Like, that's how we move forward. So I don't have a problem with Zoe. Like, we need Zoe to succeed. I want it to be successful. The idea that the microbiome regulates blood sugar is a strong one. Like, there's good evidence for that. But I suppose my concern comes in the way that those things are executed and done, which I think is really problematic. I don't want to slag Zoe off too much, but like all others off, because, I do have a problem with them fetishizing, blood glucose measurement. And it's like a learner drug for people who've got eating disorders. It's a problem when people turn up in my clinic with metastatic bowel cancer with a microbiome test that they've spent 400 quid on that doesn't actually help them. That's a problem. It annoys me. But, so maybe I agree on some of the way that those things are marketed and how they're communicated. I really believe that those things are medical devices. They're not wellness products. And I suppose my bugbear is with the wellness industry. For me, I just don't know what wellness is. It's just bullshit. It's like a way of but it's just a way of bypassing regulation. That's what it is. Because if you look at a lot of these business models of these startups, what they're basically Trojan horse business models. What they're trying to do is to sell enough tests to build enough of a database to make a product that's actually useful. That's not the way we should be doing science. The way we should be doing science is validating those tests and making sure they really do what we think they should be doing, and then applying them for very specific use cases that have value. That might be economic value, but more importantly, health value, right? So I think the problem with microbiome science where I disagree is when it gets misused, when people use it or they misuse it, I should say, to sell something that, isn't really, profitable. But like, I've got no problem with industry. I've got no problem with commercialization. I'm engaged in it myself, so I cannot be hypocritical. I do think we should be testing. I've got no problem with people selling tests. I've just got a problem with the way that they're marketed.
Brilliant. And I totally agree with that, because this is kind of why we started this podcast almost a year ago now, is that kind of feeling of that wellness industry that is taking advantage of people and actually trying to address that and try and look at it from quite a scientific basis. So I love that answer.
I spend a lot of my time in my clinic taking people off probiotics and taking them off supplements and saying to them that, like, you can't grow a garden just by only planting one flower in that garden. And it's amazing. Like, the young people in particular will come in and they'll go, I've got bloating. You go, well, okay. And you'll take this really traditional history. And the end of it, I always ask, are you on any supplements? I ask two questions now, always. Are you on supplements, and are you taking GLP-1 agonist? Because everyone's on a supplement and everyone's taking GLP-1 agonists. They just don't want to admit it. And you'd be amazed. Like, it's young men on protein powders. And then I get into trouble because I write a piece in the paper going, I think people are taking too many protein powders, and all the people that make protein powders get very upset. But it's nonsensical to me that, that you would think that you're going to improve your health by taking lots and lots of industrialized powders and somehow that's going to make you healthier. Like, it just isn't. What's going to make you healthier is by having some nuance and sensitivity around the way that you manage your health and you think about prevention. I just think that's a more nuanced and perhaps a subtle way of thinking about it.
Excellent. I'm going to move to wrap things up then. So, James, we've got a very exciting rapid fire round for you now. Before recording, we were trying to think of two words that were, hype or hubris, but obviously they mean the same thing. We've come to the...
You wouldn't believe how long we took to come up with a really bad couple of words, and I apologise in advance.
So in the theme of this episode, the two words are hit or shit.
Okay.
And we're just going to list a few things and I think you've alluded to some of these already, but you can either say hit or shit, and then you're allowed to give one qualifying sentence or a brief explanation as to why, if you'd like to, or you can just move on. So the first one I'm going to give you is probiotics.
Shit. But they can be shit. And so I mean, look, there's nearly 17,000 papers published on probiotics. There is good evidence for probiotics in some specific clinical conditions, but a probiotic will not make you live longer. So take a probiotic if you've got a particular problem and you're trying to fix a particular issue. But probiotics are no more of a panacea than, any other supplement.
Sorry, I know this isn't really in the theme of the whole kind of quickfire round, but I just wanted to pick up on the probiotics in that. So just a case in point, I know IBS, so irritable bowel syndrome, is hugely common, clearly. Probiotics, do they have a role? Your generic probiotic that you buy from the pharmacy, are they going to help in any way for someone who has irritable bowel syndrome, or is that just a waste of money?
Okay, so short answer, and then there's because this is like one of my kind of hobby horses, and I try not to get on. So the answer is that, yeah, probiotics do have a benefit in IBS, but the problem is that IBS isn't really a single condition. It's not really a syndrome. It's not really irritable, and it's not really a problem of the bowel. It's really just gut-brain interactions. That's the first thing. So it really depends on why you're taking it. But most people just take probiotics in the wrong way. So if you're going to take a probiotic for that, take a multi-strain high-dose probiotic, but you've got to take it for 8 to 12 weeks, and you've got to take it every single day. And you've still got to think about nutrition and diet. Right? So it's got to be taken as part of a broader dietary approach to managing specific aspects of your symptoms. So what you can't do is take a probiotic intermittently every few days or so and then not really work on your diet and other aspects of it and hope it's going to work. Because you're taking a live bacteria that's got to grow in that niche in your gut, and it's then got to switch on and do the right functions that you need. And it can only do that if you feed it and look after it in the right way. So it's much more about how you take the probiotic. And again, that's another reason why I test the microbiome, because actually when you sequence them with a long read precise test, which is getting you down to strain level, you can see which probiotic strains are missing in the gut. And now what I tend to do is give them in a much more targeted way. Rather than going, well, here's a meta-analysis of a particular set of probiotics for a particular aspect of functional gut problems, I go, well, I've measured your gut and you've got absolutely no Akkermansia and eosinophilia in it. Have some of that, and I will give them that. Or I will say, look, actually, you're missing, these bifs, and actually, you need them for these particular functions. Here's a probiotic, which has them. And that's, I think, a better way of doing it. And there are actually some better tools now. If you're a primary care doctor and you want to know what to give, I will send you guys a link which you can put out with your stuff, created by a guy called Glenn Gibson, who's the father of all probiotics. He used to work at Reading. I think he still works at Reading, actually. He's just created a brilliant website which gives you all the evidence base for all of the probiotic strains you might want to give, which is quite useful.
Amazing. We'll put that in the show notes as well. Okay, really quickly then, back to the not so rapid fire round. The next one I had was inulin or fiber supplementation.
HIT. That's really, that's probably the single most common intervention I would recommend to my patients. Really, really good.
But start slow, start gradual.
Just warn your relatives because you're going to start farting a lot more.
Okay, next up, vagus nerve stimulators.
So, look, I'm going to go HIT. Like, again, they work. There's evidence for them. They work. And I use them in very specific patients who've got hypervisceral sensitivity and have awful pain, like the intractable pain. Actually, they're quite useful. Are they useful for everybody? No. Do they make you live longer? No. But yes, I do use them sometimes in patients who've got hypervisceral sensitivity, and I actually, there is some evidence that they're useful.
I've seen them advertised. I've been targeted on Instagram about vagal nerve stimulators for things like anxiety and for focus. And I'm imagining that this is a bit of overreach in their use.
For that, definite shit.
Definite shit. Okay, good.
But I think I think for very specific use cases, they are sometimes helpful. And look, the thing that I would say is that I've become much more sympathetic to these sorts of things, as long as it's not harming my patients and they're not spending an absolute fortune on having to do something which has absolutely no evidence. Sometimes I think if there is a placebo effect, more good. And actually, that's the whole gut brain thing. So actually, if they really believe it's going to work, and they're really committed to trying it, and they're not going to come to harm from doing it, rarely piss on their parade. Like, I didn't mean to, but I'm going to, okay, well, let's try, because actually nothing else you're doing is working. But at the same time, I don't think a vagal nerve stimulation is going to solve your source of anxiety if actually, there are real world drivers of that anxiety that have never really been properly addressed. So in my clinical practice, sorry, I'm deviating for your fast fire around again, but like the single biggest change that I've experienced in my practice is around disorders of gut-brain interaction and my mental health history taking. My mental health history taking has completely changed. If you come and see me now with a gut problem, I'm going to spend some time talking about your early childhood. I'm going to talk about, eating disorders, trauma. I'm going to talk about neurodiversity, and I'm going to talk about things that most doctors just don't ask about. And I think it's much, much better to have a more honest conversation about your mental health and to really kind of think deeply about it before you start taking vagal nerve stimulators. That would be my key message on that.
Okay. Last two. I'm not going to name any specific brands here because I don't want to get in any further trouble, but meal replacements, like these meal replacement shakes.
So much shit.
Shit.
Hard.
Good. Okay.
Well, loose shit, probably. But shit, either way. I hate them so much. Terrible.
Fantastic. Okay. Last one is fermented foods or things like kimchi.
Hit. Like, again, hit, but hit with caveat. Like kimchi doesn't solve an internal climate crisis. Kimchi can't solve all of your problems, but kimchi as part, of a well-balanced plant-based food, changes the diversity of your gut and really good for you. And I'd recommend it. And I love it. And I eat it really nicely. And I make it with my daughter. She makes it better actually than I do. So yeah, I hit.
Oh, that's amazing. I'm going to draw things to a close and I'm going to say thank you so much, James, because we've taken up a huge amount of your time this evening. I think everyone should go and listen to some of the other podcasts that you've done, read your book. I've actually learned a huge amount from doing both of those things.
Listen, it's totally my pleasure. And thank you for the work you do too, as well. It's good. I think in the sort of infodemic that we live in, we need some sensible voices cutting through the noise. So thank you very much for having me.
Thank you, James. It's a real pleasure. Thanks for everyone who's listened. And I think takeaway point then, if you can't have fun, eat some fiber.